Hey everybody, and welcome to TGIK. And hold on, I have an intro line here. I'm supposed to say, "Hi, it is me, Kris Nova, and I am back from a 2-week-long vacation where I did not die of dysentery. I am in fact alive and well and healthy, and super excited for a TGIK today on this wonderful, fabulous Friday, the last Friday of August. And today we're going to be looking at Flannel, which my inspiration from Flannel was the fact that as I was mountain climbing over the past 2 weeks, full-time, not working in tech very much at all, just little bits here and there, I wore a lot of flannel and therefore thought about flannel a lot and knew we were doing a series on CNI and figured that it would be a good idea to talk about flannel, which in my mind is one of like the original CNI implementations and really does a good job at keeping things simple and elegant, and is going to give us a good opportunity to actually write some CNI code and see where the rubber meets the road, really deep down on the node level in Kubernetes as we start poking around at Flannel. But anyway, more on that later. And I actually have some Flannel mountain pictures I took for the episode today. We can look at those a little bit later as well. But first, it's my favorite time of the week, which is this is my first day back in Seattle, and it's really rad that my first day back in Seattle is a day where I get to do my favorite thing ever, which is to tell all of you wonderful people hello. So, without further delay, let's go look in this chat that we have here. Okay, so we had somebody join about 30 minutes early, and I wanted, do we have a prize for someone who joined 30 minutes early? Who gets the first hello every week? We should, totally make it a thing to call them out. So this week, our first hello came from Obina Ordu. Hello, Heptio. And then Olav says, dang, I'm not the first to say hello. Maybe next week, Olav. But still, hi, folks. It's good to see everyone. I said hello. Looks like George is here helping out, who, really quick, I just wanted to give a big shout out to George. Every week when I do TGIK, there's actually about 30 minutes before the episode where I'm here in the room and I'm just kind of talking to George for 30 minutes and he's slacking back to me. And it helps me kind of get in the mood, and he does a lot of the behind-the-scenes stuff, finding the links that we do for TGIKs every week, and really helps to bring this whole thing together. So big shout out to him. He really helps bring this thing together, and he's kind of like the man behind the curtain. So thanks for all your help, George, and thanks for listening to me rant for 30 minutes before the episode every Friday when I do a TGIK. So next we have Tim says, watcha. Simon says, hi. George says, in about 1 minute. He has the show notes, which I have pulled up and we'll look at in just a second. Lamaddy, it's always great to see you. Lamaddy, still one of our, long-time attendees. You're always here and you're always happy, and it's always great to see you, Lamaddy. John Gillies, hi from Phoenix. Ors, hi from Berlin. Rory McCune says, yay for not dying. Hooray. I didn't even get injured, and my hand's doing really great. I can actually show it on TGIK now, and I can, actually bend it all the way, so that's really cool. Hooray for no injuries. Amito, hi from London. I'm not going to try to pronounce that name because I know I'm going to say it wrong, but hi from Turkey. Lamaddy says, did you go to GopherCon, Kris? If so, how was it? Yes, I did go to GopherCon, and I got to spend a lot of time talking about Go and Kubernetes with a lot of people and played a little bit of rock and roll with the GopherCon band. It was a really great time. If you guys have never been to GopherCon, it is hands down my favorite conference to go to. It's really like going and seeing all of our friends. Everybody goes there, and even if people don't have presentations, they still make it a point to go. And the hallway track is probably the most beneficial hallway track I've ever been to in my life. GopherCon is a great conference, and I make it a point every year to go, no matter what. So I had a great time, and it was great to see everyone. Again, and the GopherCon band is also always fun. So let's see. Bob says, someone who comes 30 minutes early does not have enough to do. I don't know. Maybe they're just joining early, and they just say hi, and they're still doing other things concurrently. Carl, morning from New Zealand, second favorite thing, Death Star landing demos. Yes. The Death Star landing demos from 2 weeks ago before I went on vacation were really rad. Still my favorite demo I've done here on TGIK. Jason D. Tiberius, it's good to see you. Jason helped me out earlier in the SIG Cluster Lifecycle Slack channel for everything we're going to be going over today. So Jason gets to see what all of my weird questions are going to somehow get glued together to form a complete thought here. Gus says, good evening from Hamburg. After some weeks without live TGIK, could attend again. Good to see you, Gus. Next we have Carlos. Hola from Havana. Hola, Carlos. Rob Robinson. Got all my work done early today, so I finally get to watch today. Welcome, Rob. Have an extra beer for us here at Heptio, and congratulations on getting your work done earlier. Let's see, Bob Froylig says, welcome back, Kris. It was cool to meet you at Disney back in April. I don't remember when I went to Disney. It was not winter time, I remember that much. So yeah, it was good to meet you too. Let's see, Vikram, hi from Goa, India. It's 1:30 a.m. here. Oh, like, round of applause for Vikram for joining in the middle of the night. Thank you very much for joining. Hi from Chicago, North Burbs. What's up? So speaking of Chicago, I was supposed to do you can't have a cluster bleep without a cluster presentation at DevOps Day Chicago on Wednesday, and some crazy stuff went down at the airport, and I ended up missing the flight due to some software errors, which I just thought was like super hilarious and kind of ridiculous and like really annoying all at the same time. So I am trying to find a different conference in Chicago to kind of come back and have like a redemption presentation, because I've been waiting to give that talk for about 6 months and I've worked really hard on it. So hopefully we can find like another conference or a meetup or something in Chicago, and I can come out and hang out with folks and still give the you can't have a cluster bleep without a cluster talk. So next we have Chromefire. So a stupid question: why Go? Why not Rust or something different? That's a loaded question for one. So loaded questions here would be appreciated not to ask. But if you must know, Go is my favorite programming language because it compiles to a statically linked binary. I think it's simple for users. I think the standard library is simple. Kubernetes is written in Go. And I like the way that the concurrency is handled in Go. And later in the episode, we're learning about the future of Go in Go 2, and I think that is also exciting. So I love Go, and that's why. Anyway, hi from Seattle. Good to see you, Ed. In Lamati, you're going to fly Spirit airplanes next week, I bet. And Abu says hello from Bangladesh. And on that note, I finally caught up. We're going to pause there with the hellos, and we're going to jump over, and we're going to start looking at some of the This Week in Kubernetes and some of the other stuff that came out of GopherCon, and talking a little bit about high-level stuff before we jump into Flannel for the rest of the episode. So I'm going to put a little marker here next to Abu from Bangladesh, and let's jump over to my screen. Cool. So every week we do this HackMD thing where we have this live markdown on the left that folks can come to and edit. George put a link earlier. If you want to come in and add any notes throughout the episode, feel free to. George and I can approve them, and they will ultimately get added to the GitHub repository. And then over here on the right, we have the rendered version of Markdown, and we do one of these little Markdown files for every episode of TGIK. So this week, I kind of did this out of order. I kind of just like brain dump into this Markdown file every week, and then we kind of like sort it out afterwards. Looks like George is adding the link right now. And then also, if you guys remember last time, I chugged a bunch of this. Like, we just started getting this tea at the office, and it's super sugary. So I just drink this all day, and I'm like high on sugar all day, so it's really nice. Okay, so Cubicorn stuff going on here. Okay, so this is deploying a cluster with Cubicorn, which we'll get into that when we go look at Flannel later, exploring Flannel. Reference links. Okay, this is more Flannel stuff. That's the notes I had with Duffy. Okay, so yeah, here we have This Week in Kubernetes. So let's talk about what happened this week, and maybe even a little bit of last week, the week before, because I wasn't here. So the first one we have is, and this is my first time looking at a lot of these articles, so we're going to kind of try to figure them out together. A lot of folks have been contributing articles like this, so if you find one and you want to add one, please do, and we'll actually look at it live, and I'm not really going to look at it beforehand, so we'll kind of learn about it together. So feel free to share one and contribute your thoughts on it as we look at it together live on TGIK every week. So this says, introducing horizontal pod autoscaling for Amazon EKS. Okay, so in this diagram, it looks like we have two pods, and we have some sort of deployment with some sort of scale imagery that I don't really understand what that is. And it says metric server API and horizontal pod autoscaler. Okay, I see what's going on here. So this is a pod autoscaler, not a node autoscaler, meaning that if for some reason your software, you can set it up using this metric server API. If for some reason your software is detected that it needs more software resources and you happen to have resources available in your node pool, this EKS pod autoscaler will come in and actually scale your deployments for you automatically and create more replicas of your software and then distribute incoming traffic across them horizontally. And this is cool because you don't have to worry about it. One of the great examples I always like to use for the horizontal pod autoscaler is an example from when I was working at an e-commerce shop, and we had to do all of this stuff manually. So every year for the holidays, we would get a flood of traffic, like on Black Friday and Cyber Monday, where people would come online to the website. And we try to actually re-implement something like this on our own. Horizontal Pod Autoscaler, in this case, that we have from here at the folks at Amazon, would solve this problem for us and say, we're detecting an onslaught of traffic. Let's go ahead and scale our software horizontally and distribute the load accordingly. And hopefully that's decreasing the amount of server runtime errors that the user is experiencing while they're trying to buy all of their wonderful holiday presents. So this is cool. EKS has their own implementation here. And it says, why was HPA not supported previously? So you can read a little bit about the history here, and you can see what's coming up next. And as one of the organizers for SIG AWS, Brandon here has been one of our longtime attendees, and it's really nice to see that this is all kind of coming together, and we're like coming out with articles now about all the cool stuff that's going on in EKS. So big shout out to our folks at Amazon, and thanks for doing some really handy upstream open source work for the community and letting us distribute our software horizontally. So next, I'm going to skip this one because this one is a huge one that I want to get to at the end. Looks like Maddie had a question. Any idea what criteria you can pick to autoscale your AWS compute instances? I didn't look at the criteria, it just said a metric server, but I'm assuming this is all got to be runtime resources, so everything from compute to memory to disk. I don't know why you would want to scale in disk, but I do know that the HPA implementation in upstream Kubernetes defines all of this stuff for us, so you could go into upstream Kubernetes and actually see what is available there. And then also in general, like scaling a deployment is a relatively trivial task in Kubernetes, so it actually wouldn't be too impossible to implement some sort of your own autoscaler that could run arbitrary metrics on your end. I'm pretty sure the HPA supports this today, adding your own arbitrary hooks, but regardless if not, it's pretty simple API call, and there's commands baked into kubectl to help you with that as well. So good stuff here from our friends at Amazon. So next we have the machines can do the work of a story of Kubernetes testing CI and automating the contributor experience. That's a really long title. So it looks like this is an article from Aaron Krickenberger and Benjamin Elder, two folks at Google. Large projects have a lot of less exciting yet hard work. We value time spent automating repetitive work more highly than toil. Okay, so this is cool. So looks like, let's see what the work is here that we are talking about. Initially, we focused on the fact that we need to support the sheer volume of tests mandated by the complex system of Kubernetes. Real-world failure scenarios had to be exercised via end-to-end tests, PR workflow, triage, project health. Okay, so this just looks like it's talking about the contributor experience work that goes into the Kubernetes project. So for folks at home, we talked about Prow like a month or two ago. This is a really cool piece of software here that came out of upstream Kubernetes that allows us to interact with GitHub in cool ways and give us some more functionality in GitHub that we wouldn't have before just by having various commands here. So the way that this works is you would add a comment, and you can include things like /hook or /plank or /OK to test, and there's a couple of other ones. And that gives users sort of a new command line interface through GitHub comments to interact with this backend piece of software. So I think what this blog is sort of like highlighting all of the work that the contributor experience folks have done behind the scenes and how we've actually used Kubernetes to help Kubernetes, which is really exciting. And another great example of how Kubernetes can be used to help and build itself moving forward. So hats off to the contributor experience folks for this. This is great stuff. So next we have, oh, this one looked cool. I remember seeing this one earlier. It says endoscope, snoop around inside your Kubernetes pods. So it says, today I released Endoscope. This is a tool that solves a couple of simple problems. So in general, like as somebody who wrote a book and a technical author, like this was much easier for me to like grok right off the bat than like this whole paragraph here. So I really appreciate like brevity in technical articles. So this is really, really handy because we already know what this is doing. So I have a running container in Kubernetes. I wish to have a shell inside of it. And it looks like this goes in and it helps you do like some S tracing on the pod and doing some debugging live on the pod, which is handy. And if you have used the tool Crex that I built, and even a handful of other tools that are less popular, solving these types of problems has been interesting. So having a tool that sort of just does one thing, inspecting a pod and doing it well, is super handy. And let's see if I can just get this up and running in like the next 5 seconds. And if so, we will totally try to use it on a pod today when we're looking at Flannel. So let's see, how do we ping? I just want to see how to install it. Is there a release? 0 releases. I'm going to give this like 5 or 6 more seconds, and then I'm going to give up on it because we need to move forward. Container. I don't see how to install this, and I don't see clone or download, and I don't see any releases. So sorry, Scope. We're going to try to grab a copy of you later, and maybe we'll try it on next week's episode. But that looks cool. Thanks for the share there. Next, we have Weave Flux. Version 1.6 is released. Again, single sentence right here at the top, +1. This release improves existing features and have some new goodies like regex tag filtering and multiple sync paths. Have fun. Okay, so this is a new copy of Weave Flux. So Weave is a company based out of London. I'm really close with a lot of their folks. They do a ton of work in upstream. I met a lot of them in upstream, and we've been in network for years. And I think in the future we're going to look at WeaveNet, which is a CNI implementation similar to the ones we're looking at. And here at Weave Flux, we have the GitOps operator. So Weave Flux is this whole implementation of GitOps, which is this really cool thing that Alexis and some of the folks at Weave have been pushing forward, which is sort of using Git as your source of truth and having sort of this declarative model in Git, and Git as your database, which is easy for developers and operators to interact with. And then this Weave Flux operator kind of goes and reconciles this state moving forward, doing a lot of handy arbitrary things that are convenient for Kubernetes software engineers and operators. So Weave Flux is really rad. We could probably do a whole episode on Weave Flux. And I believe it's upstream open source. Yeah, it is. So here's the source code here. So we could talk about Weave Flux, and then this is just a new release 1.6 that says it improves some existing features and it has some new goodies like regex tag filtering and multiple sync paths. So exciting new release, and good to see that this really cool GitOps declarative piece of software is moving forward. So hats off to our friends at Weave. Coming up next, we have... What do we have here? Ambassador 039 released. Oh, I thought this was like a CNCF Ambassador. This is completely different Ambassador. Okay, it says, we released Ambassador 0.39. Ambassador is an open source API gateway built on the Envoy proxy for Kubernetes. What a wonderful sentence here. This release removes the statsd container by default. When initially installing Ambassador, the statsd container would send packets to non-existent statsd sync service. Okay, so this is really cool. So this is a new API gateway, and we have a new version of it as well. I want to see the source code here. You can get Ambassador running with a single Docker command. You can install it via Helm. Upgrading Ambassador. Do we see GitHub anywhere on here? Let's grep for it. Nope. I always like looking at the source code. But this looks cool. I would be interested in trying this out. And again, if we don't already have a copy of Ambassador in the TGIK issue tracker, let's check and see. So TGIK, Heptio TGIK. Let's go to the issue tracker, and let's look for Ambassador. Okay, cool. So we do have it. And of course, Lamati, always one step ahead of the game. Speaking of Lamati, I saw that you had some questions. I'm going to go back in just 1 second. Let me pull this up. Okay, let's see what folks have been saying. Lamati says, any idea what criteria? We already talked about that. Chromefire says Rust from Mozilla and Kotlin native from JetFrames are like the same, but way simpler. Sorry for that, but I'm like, why does it need to be so complicated? Is Chromefire the same person who asked about Go? Yeah, they are. Okay. Chromefire, I am very excited to learn about your opinions on programming languages and would love to read an article. If you could share one with us, we would happily take a look at it in one of the This Week in Kubernetes about pros and cons of different languages and how you feel about them. So Michael Goodness, good to see you, Michael Goodness. George says GitHub DataWire Ambassador. George, I think if you could add that to the notes, that would be handy. And Todd Lyons, maybe click on one of the issues should be in the Git repo and get to the source from that. Okay, so let's go back here. So we looked at Ambassador, and George already added that. And it says debug a Go application in Kubernetes from IDE. Let's see what this thing is. I'm curious what IDE this is. As a developer, it's always useful to be able to debug an application with its own IDE. When your application only works with the Kubernetes API, you can simply launch your application. What is this thing going on, though? So build the application. The application I want to debug is a Cassandra operator. The operator used to in the script is build.sh to build the Go application. I added an input parameter debug to the script. Looks like here's the script here. This is how we built the Docker image. Then we deploy our application. What is this? Oh, this is text template. This is Helm, isn't it? Okay, yeah, so they're making us deploy it with Helm. Then it says to deploy the operator in debug mode, you can just do this, configure the IDE. I use Goland now to debug my Go programs, but it works similarly with others. And it has this thing called remote debug, and you can, oh, okay, cool. So this is a small Go program that acts as a server, and then we can use this built-in feature called remote debug, and then we can actually go and actually do like a remote debug. Oh, this is really handy. So this is sort of solves the problem of how do I look at my code running in Kubernetes from my local IDE, and what is the good sort of path of development from going from a text line change here locally to running in Kubernetes, which as we actually try to deploy some Flannel components later today, having something like this in place would be really handy. Big plus one for me on this one. I love seeing stuff like this. Let me add a clap. Yay, clap. All right, so next we have, so George suggested we do this Powerline Go, which I'm gonna look at this last, and so we skipped over this earlier, so let's do this one now. So this is Golang 2. So this was a really big announcement at GopherCon this year, and it says on August 28th, yesterday at our annual Go Contributor Summit, attendees got a sneak peek of preliminary drafts of possible designs or changes of error handling and generics. That's right, everybody. Live TGIK 2018. The Go team is talking about generics and actually had a working example and gave folks a sneak peek of what it could look like for Go 2. So this is monumentally huge, and I think a lot of people in the Go community are excited about this. Solving generics is a very hard problem, especially when you get down into the nitty-gritties of compiling the code and how you go about reasoning about the code and how you deal with memory as you're reasoning about the code. And as always with the Go team, whenever we look at an implementation to a solution, it's always very elegant and slick. So this is a really good opportunity for you to learn about a really complex problem and how a programming language will approach solving this problem. So this is going to be very exciting to follow along as we look at it. Looks like folks in the chat are saying things. Michael Goodness says, welcome back, Chris. Just in time for a long weekend. Yes, it is, although my weekend is completely booked, not mountain climbing for a change. I'm actually going to stay in the city this weekend and take care of some stuff around the house with my new partner who just moved in. So see how that goes. Anyway, Lamatti says, got a favorite Golang 2 feature. And looks like Pavisi says, Go is C of 21 Century He. Okay, cool. So let's go back here. And let's look at George's suggestion for Powerline Go. Cool beans. So I think this is supposed to be like a new shell. I'm a very big Bash advocate because a lot of the times I've noticed that getting too much working here creates a dependency on your specific Bash profile. And especially doing a lot of demos and things like that, I am moving from computer to computer a lot. And I try to solve the problem of how do I store my Bash RC and all my Bash stuff up in the cloud somewhere so I can easily move into a computer. And that just always proved to be a problem because things like DNS, depending if I was on site with a client or something, may not work the way as intended, or certain websites might be blocked. So I ultimately, after years and years of trying to customize my Bash RC and make it as portable as possible, decided that it actually makes more sense just to learn good old Bash and just be comfortable in Bash with the way it ships. And I found that to be super efficient for me. But I told George I would check it out, and he said that it actually might be Rainbow. So we'll give this the 30-second try and see if we can't get Go Powerline shell up and running for the rest of the episode, and see if we can't get me even more confused as we look at Flannel. So it says a Powerline prompt for Bash, Z shell, and fish. Virtual env and a Nix shell. Installation uses ANSI color codes, precompiled binaries. Go get, so here's a go get command, so it's written in Go, that's cool. By default, if you will be in Go Ben, Bash, okay, we're gonna see what happens here. So let me pull up my terminal, and let's try go get powerline.go and see what happens. And while we wait for this to download. So how was everybody's week this week? So the one thing I usually like to do when I do go get is I like to do a verbose mode, so I actually see what's going on. But we're pretty blind to that, which I don't always like to see. But I bet now, do we have a powerline.go? Oh, I don't even know what that is. So how do we install this thing? Add the following to your Bash RC or Bash profile on a Mac. So let's try this, and then I can always comment it out if needed. No, I'm not going to open up my Bash RC on TGIK, so we get to look at my lovely face for a second while I edit my bash RC here to see if we can't get this up and running. So 1 sec, folks. Emacs. I'm going to kind of tell you what I'm typing here. Bash it's bash underbar profile is actually the one I want to edit. So move this out of the way. And let's go all the way down to the bottom. Oh yeah, I definitely do have secrets in here and passwords and all kinds of interesting stuff we don't want to show on the air. Okay, so let's scroll down. Where do I want to add this? Okay, so I have this big block here in my bash RC where I define a bunch of functions. Let's add it to the end of that. So I'll paste that in there, save it, and let's get this back over here. And I will switch back over in just 1 second. And screen and face. Let's see what happened here. So let's source my bash profile. Ah, okay, this looks real. I'm already intimidated by this. There's a lot of information going on here and a lot of screen real estate being taken up by a lot of things I don't really understand what's going on. It looks like it kind of expands our directory here. So I'm in home directory, the computer name is Nova, in directory Nova, which is user/knova, tilde for home, I'm assuming, then Go, then don't know what this is. Everything has a question mark, so that's kind of terrifying. GitHub, and then this is like where we are in my Go path here. It's Unicode. Just what Jason says. Okay, so let me close out of Slack really quick. It's taking up a lot of resources. Okay, I'm going to actually turn this off really quick. I don't know if I'll be able to handle this on TGIK while I am looking at debugging Flannel, which we're going to be doing a lot of debugging, so having a little bit of screen real estate there will be handy. So 1 second again while I scroll down and turn all this stuff back off. Bear with me. I feel like somebody should come up on stage and tell a joke while I'm editing my bash profile here on TGIK. But bear with me 1 second. Okay, so let's find my functions. So it says function update PS1. I'm going to comment that out, and then there's this prompt command. So let's try this. Get this back over here, and let's run our source command again. Nope, syntax error. 1 second, folks. Oh, okay, so George says, I think you were missing the Powerline font. Okay, yeah, so yeah, again, the terminal stuff is cool, and if you really are going to be spending a lot of time as a software engineer and that stuff's important to you, I think it makes sense. I just, all of my code is very, on the go and very demo-y anymore. So having something like this usually just ends up taking up more time than solving concerns for me. So let's try a new one. Okay, here we go. So we're back. So let's get this over here, and we'll zoom in. Good old bash. And let's go back to Chrome. Bam. Okay, so without further ado, let's talk about Flannel and CNI. And as we do that, I'm going to sort of start up a Kubicorn cluster using some commands I have here. And then we are going to actually create the cluster without any CNI implementation. We'll look at the daemon set, and we'll get Flannel up and running, and we'll kind of start poking around at Flannel. And then if folks have questions along the way, just ask in the chat as per usual. So if we go into our TGIK repo, I kind of preloaded the repo with some documentation here. So we want to go to github.com/Heptio, and we want to go into TGIK, and we want to go into episodes, and we want to go into episode 049. Cool. Awesome. So in here, we have this file called Kubicorn. And in here, we have this bootstrap script. So I can actually cat this thing out. And I'm going to sort of tell a little bit of a story here as we look at this shell script about kubeadmin and how this is relevant to getting a cluster up and running for us to demo Flannel. One of the things I've learned about CNI as we looked at CNI with Cilium and Calico was actually getting a cluster up and running that's configured properly for your CNI implementation was actually really important. Like with CLA, we knew we had dependencies on the kernel, and with Calico, we knew that it was pretty easy to install. It worked out of the box with Cubicorn, and that's what most Cubicorn clusters shipped with. But even then, getting everything kind of dialed in correctly still took a little bit of time. I was looking forward to Flannel because everything I've heard about Flannel and every time I've used Flannel, it's been very cut and dry. It's very simple, and that sort of makes it quite elegant. Because of its simplicity. It may not be the most secure thing in the world, and we're going to look a little bit about that later, but it installed sort of out of the box like a charm, mostly. The one thing that I found about Flannel that I wanted to share with folks, let's close a lot of this stuff, and we're going to go into my notes here. Let's scroll up. Exploring Flannel. Okay, so it says deploy a cluster, which we'll start that just in a second, but I wanted to point this out. As we're deploying our cluster, we originally deployed a cluster where we did not specify this flag for kubeadmin init. So I did this earlier today, and then if I actually looked at the Flannel pods after they got up and running, I got this error here. Let me scoot this over so we can actually see this a little bit better. That said, error registering network, failed to acquire lease, node, yada, 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 and then it ultimately shut down. So I went on this journey to figure out how to turn on Pod Network Cider and what I should define it as. So what I did was I found this piece of documentation, and I actually want to pull up the Flannel docs right now. Flannel. Cool. Actually, I don't want the GitHub. I want the actual Flannel documentation that is deprecated. Flannel documentation. I'm just going to Google it and see what we come up with. This is what I want here. So if we go into using Flannel, getting started, I think it's running Flannel is where we want to be. Multiple networks. Configuring Flannel for container networking. I want Kubernetes. Let's do Flannel, CNI Kubernetes. See what we get here. This is the one we want, and if it says there's this big note right here, if kubeadmin is used, then pass pod network cider equal to this value to kubeadmin init. So if we go and we look at our bash script here, I tried to, you can see we have our kubeadmin init thing here. I tried to actually paste this right after the -- config part of kubeadmin right here in this space, and tried to bootstrap my cluster and actually got a bunch of errors saying that kubeadmin does not support adding other options if you are also defining a config. So this led me on this journey earlier today that Jason D. Tiberius helped me out with, which was figuring out how to map kubeadmin init flags to various directives in the kubeadmin config file. So in this case, we are catting this file to etc kubecorn kubeadmin config, and it's just a simple YAML file that starts and stops here. And in order for us to get our cluster up and running correctly, we had to define this networking pod subnet directive. So this directive here is actually what maps to this flag here. And I'm going to sort of show you the source code of how we map those together. But before I do that, we're going to start the cluster because it's going to take the cluster a minute or two to start. And then we're going to start looking into the source code of kubeadmin and figuring out how to turn this thing on so we can use Flannel. So in order for us to get a kubecorn cluster started, let's go back to our documentation, and we have these commands that I can copy pasta verbatim. Here in my terminal, I am in the local 049 directory for TGIK for this week's episode. And if I just paste this command in here, we create this kubecorn state file. And then I can come in here and I can run this apply command. And this is going to get us a cluster that's all ready for Flannel, but does not have Flannel installed. So we'll let this run in the background. Also, I really love kubecorn for moments like now where I just want to just tweak how my cluster starts, and this makes it very easy to do live on the air. This is, going to pat myself on the back for this one. Anyway, let's go and let's map this pod network cider flag to, let's go back and look at this YAML file again, to this directive here. So how I did that was I found this kubeadmin API docs. So I'm looking in the API docs here, and this is just GoDoc. You can build these automatically based on documentation in your code, and if you document your code according to the Golang specification, you can get this sort of like page for free. So this is a really handy way for you to get documentation on your code for free, and in the case of kubeadmin and the Kubernetes codebase, this is actually really handy because this gives us a more visual representation of the actual source code that is kubeadmin. So I wanted to find this pod cider. So the first thing I did is I grabbed for cider. And of course, there's no responses. And I was like, okay, so we're going to have to dig a little bit deeper. So as I dug deeper, I then found, where is it? I think it's this page. No, it's not that page. Is it this one? I want to find the documentation on a kubeadmin init. So let's see if we can just Google it. Kubeadmin init. And I think there's, yeah, here it is. Okay, so this is where I started to kind of like get excited, where I thought I was onto something. I came in here and I looked at this, and it had like this whole big long config file. And if you remember, ours is about 1 kilobyte. This is significantly bigger, and this sort of defines all of what I'm assuming are the defaults for kubeadmin, and talks about all the different ways you could potentially configure it. So of course, as I'm looking at trying to figure out this, where'd it go? Using Flannels with Kubernetes, pod network cider, I figured the string CIDR would be unique enough to where I would be able to come in and grep for that here. And of course, I found cluster cider and exclude ciders. And I found cluster cider is under kube proxy, and I was like, oh, maybe the pod network cider is passing something to kube proxy. So we went down that rabbit hole, and it looked very similar to what I wanted, but it turned out that this cluster cider configuration was actually not what we were looking for. The droid we were looking for, to use a Star Wars reference, is actually down here under networking, and it's called pod subnet. So this is a really interesting example of where folks in Kubernetes have decided to name a flag a very different name than what we would call it in a YAML manifest or a YAML configuration file. And this is potentially confusing for users. It certainly was for me, and I would have preferred if it went from the hyphenated case directly to the camel case verbatim, so that we can make a clean translation and easily find it. But that was not the case. So anyway, how I ultimately found it was asking in Slack, and then after I asked in Slack and Jason helped me out, I came in and went to the kubeadmin documentation and went into networking, pulled up networking and found pod subnet, and it says pod subnet is a subnet used by pods. And that's, of course, what we wanted to find because of the way Flannel works and all of its simplicity. You tell Flannel which pod subnet to use, and then Flannel is going to set up its network around it. We did not have to do this with the other CNI providers. So I think at the end of our CNI series here, it would be really handy to have like a big like pros and cons, maybe not even pros and cons, but like differences between each of the CNI providers and all of the weird nuances we discovered along the way. So maybe that can be an artifact from the CNI series that we've been doing for the past month or so here on TGIK. So anyway, we have that defined, and we set up our kubicorn cluster. And if everything went well, yes, we should have this lovely lime green output here at the bottom, and we can now SSH into our master node. So I'm going to get a few terminal tabs set up here really quick. One into our master and one into our node, which is going to serve as our workhorse, which is where we'll be able to see all of the Flannel stuff happening. So let's open up a new tab. Let's zoom in. That looks good. And let's SSH into, and we'll sudo up. So we're now in the master here. And then let's open up a new tab, and let's go into Amazon. And let's get the name of our node. So I can come in here to AWS Engineer. Grab some tea while we're waiting for the Amazon console to load. We have 2 running instances, our master, which we're already SSH'd into, and our node here, which we also could have done this command, just for good measure here. We could have done a kubectl get nodes wide and actually got our external IP of both our master and our node here if needed. So in this case, we're going to do ubuntu at, this is our node IP address, and we'll say yes, and we'll say Pseudobash. Okay, cool. So now we have master, now we have node, and now we have our local, my MacBook here that we're using as well. So the first thing I want to point out for folks at home is after we installed this kubicorn cluster without a CNI provider, we can do a kget nodes, or no for short, and we're actually going to see that the status is not ready. And if we did a describe on these nodes, we would get some errors. And if we SSH'd into one of our nodes and we ran our favorite debugging command in the world, journal cuddle fu kubelet, we would in fact see that the network plugin is not ready and CNI config is uninitialized. And we've seen this in the previous 2 episodes that we usually kind of get here as our default starting place. So let's install Flannel. Actually, wait, before we install Flannel, let's deploy a pod that doesn't work so that we can watch Flannel fix that pod. So I'm going to do my famous krun nginx -- image nginx command that I use all the time. Oh, let me run that on my local. Krun nginx -- image nginx. And for the episode, I'm going to create this alias. Oh, wait, it might already be there. Yeah, OK, so I have this alias called kdump, which is essentially kdump is equal to kubectl get all -- all namespaces. And if I run kdump, this is just like list everything in the cluster, which I have been using this more and more recently, and I kind of really like the idea of just listing everything in the cluster, especially for a Devo like what we're doing today. This gives us a really good overview of what's running in the cluster, and usually if you're going to look up a pod, you're also going to be looking up its corresponding deployment, or maybe the service that's attached to it, or the daemon set that's attached to it. So being able to kind of dump everything in the cluster is handy, and it saves a lot of keystrokes of always having to be like, kget po -- this namespace. Okay, I got my pod. Kget service -- namespace. Okay, now I got my service. Or I could just get all that in one command and kind of piece it together as needed. So it is like a list everything root command, which is potentially dangerous, but it's read only, so I feel like it's not that dangerous, and it's handy. So if you want to save a little bit of time, having an alias like this that works for you might be of use. Let's see what folks in chat are saying really quick. It seems like Calico and Flannel are kind of the default providers, so much so that you can combine Flannel and Calico. It's called Canal. Yes, and Michael, we're going to look at Canal a little bit later and how we talk about Calico and Flannel as the default providers and what they do, and how Canal sort of glues those two together, and the history behind how that project came to be, after we explore Flannel a little bit and kind of get an understanding of what Flannel can do and how it's different than some of the more like feature-rich providers like Cilium or Calico. Good comment, though. All right, so now if we do a kget po, we can see that our pod is pending, and if we do a describe on it, I feel like we've done this a bunch before, but I like to kind of compare apples to apples. We can, of course, see that, kdescribe po nginx, warning failed scheduling, default scheduler, 0 of 2 nodes are available. Because our kubelet isn't registering it as available because we're missing a CNI provider, the status is not ready, so the scheduler says we can't schedule anything, and therefore our pod is not being scheduled on any node. So we have a broken pod. So we need CNI in place in order to fix that. So let's install the Flannel CNI. So if you go back to this documentation here, which is if you're trying to find the kubeadmin, which is how Kubicorn creates clusters, documentation on creating a Flannel CNI implementation in your cluster, it was actually kind of hard to figure out the kubectl install command for this. And if you come down here, it says older version of Kubernetes, and it has like this legacy.yaml file here. But actually finding the one-liner anywhere up in this section, I couldn't really find it. So that was kind of confusing for me. So what I ended up doing was exploring the GitHub repo and found the one-liner I was looking for. So we scroll down, and we have kubectl apply -f, raw GitHub user content, CoreOS Flannel master documentation, kubeflannel.yaml. And as we all know, it would not be TGIK unless we looked at some YAML. We can look at it here. Actually, let's look at it in the terminal. That might be easier on folks' eyes. So let's do a curl, and let's look at this YAML here. Let's scroll all the way up to the tippy top and see what the folks at Flannel are suggesting we install in our Kubernetes cluster. So that starts here is our curl command. So the first thing we do is we configure RBAC. Big round of applause. We all love role-based auth control in our clusters, and it looks like Flannel does a good job at defining a handful of various cluster role rules And of course, we have a corresponding cluster role binding set up in Kube system. This is particularly important in CNI to have some sort of RBAC in place here because we are dealing with things in the Kube system namespace. So having this in place is very critical. Then we create a service account. Again, it's called Flannel, and it's in the Kube system namespace. And then we have this config map, and let's see what's in our config map. We have this JSON file, and it says we're going to create this interface CBRO. So let's actually go here and just do a quick see what we have running already. Okay, so we have ETH0 and Docker 0. We know Docker's running, so there's our Docker interface, and we have ETH or ETH0. Here, let's do a quick vote in the chat. Let's do number 1 if you think it's pronounced ETH, and let's do number 2 if you think it's pronounced ETH. So that is going to look like, let me put this in the chat. 1 ETH, 2 S. Interesting to see how you guys pronounce it. Anyway, I'm going to say ETH for the rest of the episode because it's short for Ethernet or Ethernet. Oh my gosh, everybody's coming in and voting. Like, I love watching this. Most people are voting for 1, it looks like. Okay, so we're going to say ETH. We'll say ETH on the episode then. Okay, so we create this new interface called CBR0. We tell it we're going to use a plugin of type Flannel, and we're going to set hairpin mode equal to true and is default gateway equal to true, and we'll see a little bit more what that means in a moment. And then we have some netconf.json where we use this network, and our backend type is VXLAN. We're going to look pretty deep into the Flannel source code a little bit later. I'm already getting the feeling this is going to be kind of a longer episode, so go pour a cup of tea if you are interested, because we're going to actually look at the Flannel plugin and actually the Flannel daemon and potentially make a code change to them and run some Flannel commands and see what happens. So anyway, we're going to learn more about the different types of backends in Flannel, where VXLAN is the most common. And we're going to learn why, in this case, of this particular implementation of Flannel, why VXLAN is actually not as scary as most folks think it is, particularly because all the information we would use multicast for in the past is already provided for us in the node object. So we don't even need to use multicast, and we only use VXLAN for encapsulation. So this is actually a pretty solid implementation of VXLAN now that all the multicast noise is out of the way. And thanks to Duffy for helping us learn that one earlier today. So the part of the daemon set that kind of struck me as interesting was the amount of daemon sets we were deploying. So if you come down here, we have this daemon set called kubeflannel AMD 64, which already I'm like, okay, AMD 64-bit architecture, sounds good to me. Then I went through and read this whole daemon set, and we'll look at the daemon set in a second. But what I wanted you to see is as we keep scrolling, we found this other daemon set. This one is called ARM64, which of course we're not running an ARM processor in Amazon. And then I kept scrolling, and then I found this other daemon set, and this one of course is called Flannel DS ARM, and I kept scrolling and I found this other daemon set, which was DS390X, and then I kind of was like, okay, so we're deploying a lot of different architectures. I wonder which one's going to win or what's going on here. And we're going to look at that, what actually happens after we do our kubectl apply. So let's go ahead and clear our screen. Bam. And we have, nope, don't want that. Let's grab our YAML URL, which is here. And we can do a kubectl apply -f this YAML that we just looked at. Sweet. So there's our cluster role and our cluster role binding, our service account for Flannel and the Kube system namespace. And then we have all of these daemon sets for all these different architectures created. So using our handy dandy kdump command, I'm going to create a different terminal that's going to be a little bit smaller, just so I can do my kdump command here, and I think it'll print a little neatly. So folks, if you're watching on TV, you might want to stand up and go a little closer to the TV so you can see this. But if we run a kdump, this is presented very neatly on my screen, and it doesn't look too terribly small, hopefully, for folks at home. So we have, where are our daemon sets here? So we have deployments here, which this is our Nginx deployment we created that is implicitly or inherently broken. And we have all of these daemon sets here. And if you look, we have 0 desired, 0 current, and 0 ready. So it looks like these sort of came in and configured themselves and detected the architecture and said we actually don't need to do anything. So now we have these daemon sets running that are effectively no ops, which seems a bit weird. But the AMD 64 did actually go and win. And I'm curious if we look at our daemon sets, if they actually define 0 or if they're updated after the fact. I guess we don't have to find it right now. If folks at home want to go and look and see if how many replicas we're defining, that would be handy. Anyway, let's go back to our kdump command here. So we have our daemon set for AMD 64. We have 2 pods that are current and 2 pods that are running. So this is pretty exciting. Remember earlier I mentioned Flannel is a pretty simple program. If we actually pull the logs for our pods on the node, we're actually able to see some exciting things happen. So how we want to do that is we want to do kgetpo namespace cube system o-wide. And we want to find our Flannel pod ds-amd64 running on, what was our kget node o-wide? So our master is 5233. Oh, we're not going to be able to map that here. Oh, yeah, we are. So our master is 0086. So mapping that up here to 0086, we can now get our Flannel pod name here. So, oh, no, we want to do the node. Just kidding. So we want this Flannel pod here. Okay, that's the one we want. Copy that. Wait, there we go. Now it's being copied. And klogs namespace cube system -f, bam. It can be, Tom says it can be a cool feature if you have a mixed CPU ARC cluster. That's a really good point. I didn't even think about that, where you would have multiple nodes running different type of architectures. You could deploy this sort of ambiguous daemon set, or the set of daemon sets for different architectures, and it'll sort of reason about where they need to be ran. That's pretty cool. I haven't thought about that, but that makes a lot of sense why they would have done it that way. So anyway, looking at the Flannel pod in the cube system namespace, we can see that, yes, Flannel is in fact using IP tables to configure some things behind the hood. But let's see what else Flannel is doing here. So in this case, we're going to go through the logs kind of one by one. It created a subnet manager. It's installing signal handlers, which every good program deserves a good signal handler. And if you're going to write it, I feel like I say this all the time, if you're going to write a signal handler, you better make it POSIX compliant or POSIX compliant. Another round of voting for people if they say POSIX or POSIX. And then the backend type is VXLAN. So I guess now is a good time for us to look at the various types of backends in Flannel. So let's go back to Chrome and let's find the Flannel source code. So so this is a new button that showed up in GitHub and it's been driving me absolutely crazy. Every time I come to this repo, I have to hit show all files and it doesn't remember that. So if I navigate away from this and go to the issue tracker and then come back, let me refresh this. Of course, it's not going to do it now. There it goes. I have to click the show all files again. So that's been an extra mouse click just to see what's going on in the repository here. Probably because it's so long, but who knows why. Weird new GitHub magic. Okay, so here in the backend directory, you can see we have all of these variable backends. And these are familiar protocols for anybody in the DevOps scene. You're probably already recognizing ones like VXLAN and IPsec and UDP. And it looks like we have something for GCE, and we have a handful of others as well. And if we go in and we look at the code here, we see there's this common code. And you can see that we have this interface where you define an iFace and you have an external address, and they're both of type netIP. And then we have this type network that has an MTU that returns an int. And you can get a subnet lease, and you can sort of call run and pass in Go context. So regardless of the type of backend you want to run, it looks like Flannel can use various different protocols, and we'll be able to call run on them and pass in a Go context at runtime. And I, of course, earlier went into the source code here and validated that, in fact, was what was going on. So in this case, we are saying that we are using network type VXLAN. So VXLAN config, and we have some configuration here. And then we wrote a subnet file to run flannel subnet.env, and we're running the backend. It says waiting for all Go routines to exit, which this is actually in the main functions, so that everything else is happening in the Go routine concurrently. And this is still back almost closer to the top of the stack at main. So the first thing we see is we delete some IP tables rules, we add some IP tables rules, and this is really handy. I remember when we were debugging Calico, it was a little bit more challenging to figure out what was going on in IP tables. Here we can see them a little more concretely, and we can start to get an idea of what the Flannel daemon is doing for us behind the scenes. So what I want to look at now is gluing together the Flannel plugin to this, and then actually looking at how the kubelet is calling the Flannel plugin, and then we're going to talk a little bit about, well, anyway, let's just start there and we'll see where we go. Okay, so what I want to do now is open up our node here and go into our opt CNI ben. And here we've looked at this directory in a lot of previous episodes. Simon says node selector, beta Kubernetes IO arc. AMD 64 would be interesting to see how other CNIs can handle this. There are a lot of dots in there and I had to remove because Google detected a URL. Thanks for the update, Simon. So here in our CNI ben, we have all of these binaries. And I went on another little experimental journey this morning because I remember learning in a previous episode when we did Calico that these binaries came from installing this package, apt-get install Kubernetes CNI, and of course it's going to say it's already installed. And this came from this change directory, etc. What is it? Ubuntu sources, I want to say, sources.d. etc. Is it apt? Sources? Yeah, sources list.d. So here we have this Kubernetes list, and you can see we have this Kubernetes Xenial main repository defined, and that is what actually gave us the Kubernetes CNI package. So I was like, I want to see where this is coming from. Where do these binaries actually get generated, and where's the source code for all these, and how do we have this sort of official plugin library that I don't understand where it comes from, and if I wanted to contribute to it, how would I go about doing that? So what I found was this cool organization called Container Networking on GitHub. And in container networking, there's this repository called CNI. This is how I should have started off our CNI series in Kubernetes. If you get a chance and you have 5 minutes of time, go and read this line by line. It'll be one of the most important things you do, and it really does a great job at explaining what CNI is, how it works, and why it's relevant, and it actually has a really great list of third-party plugins. So there's a lot here. I didn't realize there was this many of these until recently. And so far we have covered Calico and Cilium, and we're looking at Flannel today, which is also kind of a part of Canal, which we're going to look at a little bit later. And we've had folks bring up Multus and a handful of other ones. And I think Weave is coming up in the agenda soon as well. So if there's any of these that folks want to see a TGIK on, I'm happy to do a TGIK on it. And here is what I consider the most complete list anywhere on the internet. And then it talks about how you can contribute to CNI. But what I wanted to point out is if you go to the container networking org and look at the repos, here we have this plugins repository. And lo and behold, we have Bridge, IPVLAN, Loopback, PTP, and if we go and we look in our opt CNI ben directory in our terminal, we're going to see a lot of overlaps. Here's PTP that we just saw up there as well. And we see, Mac VLAN, Loopback, the others as well. So the binaries that are in the Kubernetes CNI package can actually be built from this repository. And to demonstrate that, I have already checked the repository out in my local workstation here. And we can go to my Go path, source, github.com/containernetworking/plugins. And if we list this directory, we have this lovely build.sh file that I already looked at this earlier and ran it, so I know it's safe. If we actually do this, it's actually going to build these plugins for us. And I was already my brain's kind of wondering, oh, cool, how can we start hacking on Flannel and various other types of CNI, as these are the CNI compatible plugins that the kubelet will actually execute and will somehow communicate back up to the broader daemon, in this case the Flannel D daemon, which we're going to look at it in a moment, with information about building a pod network. So, me being the hacker that I am, I came in and I said, okay, let's figure out what these are compiling to. So I found this directory ben, which we just create all these binaries, and if you do a file on it, on Flannel, you'll actually notice it is a Linux executable. So if my Golan's messing up. I don't know why I did that. Okay, so if you actually try to run Flannel on my MacBook, it's going to yell at me and it says cannot execute binary file because it's on the wrong archetype. So how I have been developing this, if you come in to our README here, scroll down quite a bit, I can run this command and actually get a Golang latest container running, and I'm going to map my container networking plugins directory to go source github.com container networking plugins on the container. And if I go inside of the container to go source github.com container networking plugins, you can now see that there's this bin directory. And if I go into bin, I can actually now execute Flannel. And of course, this is the same behavior we would get if we ran it here on the actual server in AWS. So let's go to opt, CNI, bin, and let's execute Flannel. And you can see this corresponds to this. And if I pull up my IDE, we now have the, let me minimize this one and open up this one. We now have the source code for the Flannel plugin here in my IDE. We can run and develop very quickly in a container, and then all we have to do is scopy that up to the cloud. So let's go ahead and actually see what the Flannel plugin is doing. And this, for me, answered a lot of questions of like, what do CNI plugins even do in the first place? So if you come in here to the, where is it? I think I want to say it's package. No, it's plugins, meta. Okay, so here in the CNI plugin repository, in the plugins directory, there's a subdirectory called meta, and inside of meta we have Flannel. And here you can see we have flannel.go. And this is where the rubber meets the road. This is actually the layer of software that the kubelet will execute whenever you create a pod in Kubernetes using Flannel. Which of course this is very exciting because we can create a lot of pods in Kubernetes and we can see what this whole thing is doing. So again, this is code that came out of CoreOS, now part of Red Hat, and this is all available in the upstream container networking organization. So I came in and I started looking through this and I found that there was this missing function here, which mapped very cleanly to this whole like environmental variables missing output that we get, and I started to kind of get excited because I found finally where all of the CNI implementation-y stuff is coming from. So as we scroll down, we can see that there's a lot of functions here, but the one I want to point out is all the way down here at the bottom, and it's called main. And it says to do implement plugin version. So right now we just return version all, and if you look at skeleton plugin main, we pass in function, not function pointers, but a reference to a function called command add, command get, and command delete. And if we go look at the plugin main here, it says, let me scoot this over a little bit. Plugin main with error is the core main for a plugin. It accepts callback functions for add, get, delete, and version. And you pass those in here as well for command add, command get, and command delete. And if you go and you actually look at the CNI specification, which is here, you can actually see where it defines the get, add, and delete defining CNI, which we can look at that here in a second. That's just a spec. And I don't even think this is the right repository for it. Let's see, maybe it's CNI spec. This is the one we want. So there's get, here they are here. So this defines what add should do, what delete should do, and what get should do. So let's add this to our notes here. Exploring Flannel. So I'm going to do the CNI spec that the Flannel plugin implements is here. Okay, cool. So the first thing that jumped off the page when I was going through all of this and figuring out about add, get, and delete CNI functions was when we look back at our flannel.go, our command get has this big to-do that says implement and just returns an error that says not implemented. So I don't think the Flannel plugin actually implements get, so I don't know if that's a problem or if we need that or not, but I imagine it's fairly important since some folks got together and wrote up some documentation that says you should implement it. So in any case, something could potentially be looking for information from the Flannel plugin and is going to get an error that says not implemented instead of any meaningful information along the way. So that was the first bit of worry that I noticed here in the source code of Flannel. And then I saw a command delete. Looks like it was fleshed out and it actually does some things. And then more importantly than anything else, I found this add command that starts right here. And what I did before the episode is I came in and I added this big snippet down here at the bottom that says, let's look at CNI on TGI case. So all I did was I pulled the container ID out of the input that the kubelet is passing to the CNI plugin. In this case, it's Flannel. After I defined the container ID, I then put together this string that I call file that's in the temp directory. It's prefaced with the prefix CNI hyphen, and then we pass in the container ID. We then write the file, permission 755, and we stick a handy log message in standard out to say that we wrote the file. And if all goes according to plan, I should be able to build this binary, which is a statically linked Linux binary, scopy it up to our node, create some pods, and actually see what the kubelet is doing whenever it vendors out to a CNI plugin, in this case, Flannel. So let's go ahead and build this and do this. Which for me, like the hacker in me is like, finally I get to actually see how like this whole thing, like weird system gets glued together. And Flannel made all this possible by being a very quick, very dirty example of how to do this. So thank you for keeping things simple, Flannel. It's my favorite type of software to work with. So in this case, we are going to go up a directory, and we are going to run our build script, sh build.sh. I think we already ran this, but for good measure, we're going to go ahead and run it again. Looks like we got an error here, Linux unexpected operator on line 5. Maybe we can open up a PR. Let's see what's going on here. Line 5, if uname is equal to Darwin, then, oh, okay, so this is why it generated a Linux binary, which actually ended up working in our favor, since that's what we need anyway. So interesting syntax error there. That turned out to be a good error. And now we're generating all of these binaries. So on our node, which is here, we can exit out of our SSH command, and let's go into our command where we just built these binaries that are mapped back to our local file system from our container over that volume that we passed into Docker run. So go source github.com, container networking, plugins, and in here we have bin. And let's see if this thing is done building yet. And it is. So now we should be able to pull our SSH command, and we can turn this into an scopy command. And we want to copy. Vikram says, I guess we can successfully invoke the CNI plugin executable to add a container to the network by setting relevant environment vars like this, sans kubelet, I mean. Yes, we can. But in this case, I want to be able to show how we could do that through the kubelet and through the kubectl create pods command and actually see the full system in place. But yes, you could very easily get your local workstation up and running and invoke the CNI plugin locally if you wanted to, just by defining those simple commands. Thanks for the good tip, Vikram. So scopy bin, wait, where are we? Oh, we're already in bin. So Flannel to Ubuntu at this. This is the syntax for scopy for just drop it off in my home directory, just to add a simple colon to the end. So you do that, and we just copy that up to our home directory. So now we can SSH back into our node. Remember, this is our node, not our master. This is where all of our work will be scheduled. And the fact that we only have one node in our Kubernetes cluster is making this whole exercise much easier. Otherwise, we would have to map the pod to the node, then SSH into that node, and then see all this other stuff. But by only having one node, we make this whole thing much easier. Okay, so what we want to do now is we want to sudo up, and let's move this Flannel, and this is like the malicious hacker coming in and hacking your CNI. All your CNI are belong to us. Bin Flannel, and if we list that directory, CNI bin Flannel, you will see the user and group is Ubuntu. So let's go ahead and change that really quick to root opt CNI bin Flannel. Bam, and then let's run our list command again, and we're good there. And if we actually execute this command that we just created, it looks exactly the same. But if we go to /temp and we list, we can see that we have some files here. Let's create some pods in Kubernetes and actually see what happens behind the scenes. So we want to do that by going back to our, remember this is a container running on my MacBook. So we're going to exit out of this container, and we should be able to kgit-po. We see that Nginx is running. We can edit our Nginx deployment by typing k-edit deploy Nginx, where we have replica count set to 1. You can use kscale, but in this case, I just like to do things a little more verbatim. And we scroll down here to our replicas equal to 1. And let's go ahead and let's do replicas equal to 10 to see what happens there. So we do that. We go back to our node. Like, drum roll, please. We should be able to list, and huzzah! The kubelet has successfully executed this new Flannel plugin command that we just built and hacked into our system. And if we actually cat out one of these files, let's cat out this first one, CNI1, and remember this is the container ID, which will be interesting because we can actually map this to Docker later. We can see that there's some JSON that's being passed in, and here are these configuration parameters that we saw earlier of hairpin mode equal to true and is default gateway equal to true. And remember our CBR0 interface, which did not exist before we installed the daemon set for Flannel. But if we run ifconfig now, you can see now that we, in fact, do have not only a ton of these veth, I think we decided eth, right? veth interfaces, but we also have this CNI1, and then we should have, I thought we should have CBR in here too. Maybe I'm crazy. It might be on the master. Anyway, we have eth0, and we have all of these as well. So that's exciting to see how Flannel is starting to interact with the various containers under the hood here, and how the kubelet is calling out to the Flannel plugin tool. And remember, the whole point of CNI, well, the two main points of CNI are both to enforce what am I trying to say here? Network policy in Kubernetes, and also to build the pod network. In this case, Flannel is only building the pod network. It's only solving the networking commands. In fact, by design, Flannel has no concept of network policy in Kubernetes. And if you go to the documentation for Flannel, wherever that is, CoreOS Flannel, right here on the main README, as we scroll down, it says Flannel is focused on networking. For network policy or other projects that do enforce network policy, you can use Calico. And at the end of the episode, we're going to look at Canal, which is this wonderful hybrid of both Flannel, which we're looking at today, and Calico, which we looked at a few weeks ago. And that's how the three of those sort of fit together. And we'll look at this really cool diagram, and I might even draw a diagram too if you guys are lucky. Okay, so we're able to demonstrate that the kubelet is in fact calling that binary. We're able to see container IDs, and let's go and let's find these container IDs again, and let's do a docker ps -a. How can I make this prettier? Ugh, that's not going to be pretty. Well, I wanted to be able to map our container IDs here to the container IDs in temp, but we might not be able to do that elegantly because of the amount of output here. Well, either way, the kubelet is passing in the container ID to the CNI, and then expects the CNI plugin to do something, and then, of course, the Flannel daemon is going to go ahead and take action and create what it needs to create in order for those networking rules to exist. So let's go back and let's actually tail the logs of the Flannel daemon as we mutate our pods and see if we can get the logs to do some interesting things for us along the way. The two things we're going to be looking for is IP tables mutations and route table mutations due to Flannel doing its magic behind the scenes as the kubelet hits the plugin and then as the daemon responds to that. So how we want to do that is we want to get the pod in our kube system namespace for Flannel, which we need to do an O-wide because we want the one on the node, which we said the node was this 100.204. So this is the name of the pod we want, and we can do klogs, name of the pod, namespace, kube system, and this is starting to look cleaner and cleaner. Let's do a -f. Okay, so can folks at home, let me zoom out a little bit. There, that looks pretty good. Okay, so we're just looking at logs, so not super important if you can't read exactly every one of these little characters. Really all that you need to see is that it does in fact move when we do make a change. And we can also look at on the node, what is it, IP route show, I think is our command. Let's try this again. And we can see that we actually have some route table rules defined as well. So as we create nodes in Kubernetes, which we can do by coming into Amazon, and changing our Autoscale group, we can actually watch CNI sort of reason about all this and make changes to our underlying system for us, which is what Flannel is doing. So Autoscale groups. Oh, Amazon's console just does this thing in like really weird times where it like zooms all the way up where you can't see anything. So if you didn't know that trick, there's this button over here that you press and it like helps you out, and whenever it looks like nothing's loading. Really weird glitch. I've noticed it for like over a year in Amazon. I wonder why nobody's ever reported that. Anyway, so let's go to our node. Let's edit this for our ASG. Let's edit this for our ASG. Let's try this one more time. Let's edit this for our ASG. I don't know why this is not letting us edit it. I want to be able to demonstrate that Flannel is actually going to make changes for us. Okay, so that doesn't seem to be working right now. We can come back and try it here in a little bit. And then I wanted to really quick, since we're already an hour and 15 minutes into the episode, talk a little bit about the differences between Calico and Flannel and Canal, and then hopefully we can demonstrate some IP table mutations as we create pods and define some things in Kubernetes. Duffy says you've collapsed to below the window. The UX is rough. Oh, Brad Brown agrees. Oh, so let's go back and let's see. What did I do? Oh, did I really just do this? Oh my gosh. Okay, so yeah, this UX is rough, to say the least. Okay, so in our node, let's change this. Let's bump up to 3. Why not? So minimum 3, maximum 3. Does what happened now? Amazon is hard. Okay, so 3, 3, and 3. Let's come over here and let's save this. Duffy says, so many times that has burned me. Same here'sies. Thanks for your help, folks, Brad and Duffy. Okay, so now we should be able to come to our instances, and hopefully we should see some new instances coming up here as we scale our cluster. Okay, we'll check here in a moment. But let's make sure we have everything kind of back here at the ranch ready to go. Okay, so there's our IP route show, and let's add some space here so we can see if any new IP tables get written on this original node. And then more importantly, we can watch the scheduler distribute these 10 Nginx pods we created across these nodes, and we can see how Flannel is going to like do all the interesting routing between each of these pods as they come up on each of these nodes horizontally. So while we wait for that, we're going to look at, because that's going to take about a minute or two for each of those instances to come up. We're going to look at Calico, Flannel, and Canal and learn how all 3 of them kind of fit together. So if we go to the Canal GitHub, you'll notice it's under the Project Calico organization. So the folks at Project Calico, aka a lot of the folks from Tigera, our friends in San Francisco, have put together this really interesting hybrid CNI solution. So if you remember earlier, hold on, I'm gonna have actually I'm gonna draw a diagram here that basically looks like the same one, but I'm gonna draw it so that I feel like I'm doing it for him. Did both Kubernetes network policy as well as setting up the pod network. And then we have this higher sort of like abstraction layer that we're going to call Canal that sort of sits on top of both Calico and, in this case, Flannel. And so I'm making these bottom squares a little bit smaller, which is different than the diagram in the GitHub repo, because I want to talk about all of the different things that each of these components are doing. So the first one is, with Canal, you get Calico, which is going to do, which we know does both network policy, so I'm going to say network, and it also does actually network policy. Calling that net's going to be confusing. Let's call this, let's make this a bit bigger. Let's say this is network policy, and down here we're going to say this is pod network. And we know that Flannel only does pod network, which is how we are routing from pod to pod according to whatever we declare in Kubernetes, basically. So in this case, Calico will be only doing network policy, won't be doing pod network, and we're actually using Flannel to do our pod network, which is actually significantly simpler than how Calico does it, because Flannel just sets up a single bridge for everything and then routes everything through that bridge. Whereas Calico does it a little bit more in a more complex way, and if you actually look at the underlying implementation, there's a lot going on there. So you're sort of exchanging this like complexity for simplicity, and you get this hybrid solution of Canal, where you have this wonderful implementation of network policy with Calico. Remember that Calico actually goes above and beyond Kubernetes network policy and actually defines its own network policy in a similar way that Cilium did, but you're also getting this very simple, very elegant implementation of Flannel behind the scenes as well, which is one of the reasons why Canal even exists and is this really good hybrid solution of Flannel that we're looking at today and Calico that we looked at in the past. And if you look at providers like Kops and Kubicorn and a lot of the major cloud providers, getting Canal up and running on them is not impossible, and maybe in the future or at the end of the episode or at the end of the series, we can look at Canal as a CNI implementation. But for this episode, I kind of wanted to do the two bare components, like the two primitive components, and then just talk about how Canal is just basically a configuration layer that configures them on top of each other. So let's go back to my screen, and you can see that there's a very similar diagram here on the Canal GitHub repository. One second, I just want to pull up the chat and make sure that nobody's saying anything in the chat. Okay. Cool. So let's go back to EC2 and see what's going on with these instances. So refresh. And looks like we have some nodes up. Let's go back to our terminal. And we'll go here, which we know is my local MacBook. Zoom in a little bit. And we can do kget nodes. And we can see that we have more nodes defined. And let's go and let's see what's going on. Ooh, we have a broken pipe here. That's interesting. Okay, so if we do an IP, let's sudo up first. Pseudobash IP route show, you can see that we've actually got new routes defined as new nodes come up, which is very exciting because now we're actually mutating the route system, or the route file, route table on our local node to talk to the other nodes in our cluster as they came up. And if we look at our IP tables rules here, I don't see anything has changed. I was hoping that we would get an IP tables mutation. Let's see if we can create some pods and create some host network services on top of these pods and see if we can't get some IP table rules to pop up underneath on our node. And to make that a little bit simpler, we're now going to downsize our cluster that we just upsize so that we know that all pods are running back on a single node again. So let's go back to our Autoscale group. And let's just change this back to 1. So actions, edit our ASG, change you back to 1. And we should very shortly be confident that all of our pods are back to running on either the same node we were on before, hopefully, or a new node, which we will SSH into as well. And if we look at the source code here for Flannel, this is the Flannel daemon that's actually going to be mutating the IP tables rules as we edit a service. Tom says IP tables is only used for natting traffic from pods to addresses outside of the pod network. I think I was able to get an IP tables mutation by adding a host network in one of the services, but if not, we're going to give that a go and see what happens, and if not, then we can hopefully try to find an example later downstream on another episode where we do some natting and actually see the IP tables doing the magic translation for us from going from one pod to some arbitrary rule outside of the cluster, which is good to know. Thank you for the good pointer there, Tom. Let's go back here. Okay, so we lost our log because I'm assuming the scheduler rescheduled that pod somewhere. So let's see what we can do here. Okay, so those instances are still up, so we still have pods for Flannel. So let's give it a few more moments, and let's see if we still have our instance here. We do not. So let's go back to Amazon and see what's going on in Amazon. And we'll have to find our node that's left over. I'm assuming it's first in, first out with ASGs, which is a really good question. If anybody knows the answer, how ASGs work with instances, if they're random, if it's FIFO, what is the algorithm of how Amazon will create and destroy EC2 instances as it scales up and down. So that one's shutting down, and here we have this one, which we can copy this to clipboard. So Tom says the pod network is static. It's the big /16 range. Each node gets allocated a smaller range by default, a/24. So let's SSH Ubuntu at blah. We have a new IP address. Let's sudo up. Let's make sure we have some containers running. We do. And let's go back and let's run this command again. much shorter than before, so now the rest of Kubernetes is finally catching up. And let's look at Flannel running on our new node, which is this pod. Klogs, paste, dash namespace, kube system, -f. Bob says ASG policy by default kills the old pods first. I'm assuming you mean old nodes first, and is configurable. Tom says the NAT rules are just saying if the packet is from inside the /16 and destined for outside the /16, it gets natted. Okay, so Tom, that makes a lot of sense. So basically what Tom is saying is if it's going from the broader /16 to the smaller /24, then we need to do network address translation, and that's where the IP tables rules comes in to actually do that network translation for us so that we can route into and out of those two subnets, which is handy to know. And Bob confirms, yes, he was talking about nodes. Okay, so I really want to do this because we tried to do it in Calico and it didn't work. Let's see if we can simulate that by adding a new service and poking a hole and hopefully getting Kubernetes to do some natting for us on the pod level. So how we want to do that is we want to try to open up a load balancer for our Nginx deployment here. So while that's tailing, let's go back to this other local one, and let's do our kdump command again. And let's see if we have services. We have Kubernetes and we have kubedns. So I want to create a service for our Nginx pods. I'm trying to think of an easy way to do this other than, what is it, kexpose, kubectl expose. What is the syntax here? You must provide one or more resources. I might not be able to remember how to do this off the top of my head, but it would be really handy. We might not have time to do it this week. Let's see it, like if we can Google this in like the next 5 seconds if we can. Kubectl expose deployment. Exposing external IP address. I think this is what we want. Here we go. This is exactly what we want. I knew there was a command for this. Okay, so let's go back. So kubectl expose deployment. So the name of our deployment, which is Nginx. Yeah, Duffy got it as well. And Tom says, if anyone is interested in the nitty-gritty details of how Flannel does VXLAN, I document in the top of vxlan.go file in the Flannel repo. Thank you for that, Tom. We can look at that here in a second. And Duffy is continuing with our exposed deployment, which I think I got here in front of me. So I think we're good. We're just going to go forward with this type load balancer name. We're going to call this TGI Nginx service. Couldn't find port via the port flag. Port 80. Exposed. Nothing there yet. No IP tables rules yet. Interesting. I'm assuming there would be some sort of NAT that's happening there. Duffy says you likely don't hear this enough, but awesome work on Flannel and Calico, Tom. +1, Tom. It's been great. The work you've done is fantastic. I'm a big fan of Flannel. I like how simple it is, and I know this stuff is not easy, and we kind of just take for granted sometimes how we can just run a magic kubectl apply, and all of this stuff happens behind the scenes that most people don't even know is needed or even really understand how it works, and the fact that it does work is fantastic, and that we have all these different ways of configuring it and making it work are also really wonderful. So seriously, +1 to Duffy. Thank you for your hard work. Tom and all CNI engineers for that matter, because we wouldn't be where we are today without you. Yeah, absolutely. You're welcome, Tom. Okay, so still trying to work on IP tables rules here. Open to ideas if anybody wants, like the goal here, we just want to see the Flannel daemon add an IP table rule. Let's go back and look at our pods and services and see what's going on. So kget service. We have this load balancer. It, of course, has a new external IP address, which I'm not going to put on the air, but let's just edit this service and see what it looks like. My infamous Kris Nova Emacs configuration. Cluster IP, labels, Nginx. So it is mapped to the Nginx deployment. Target port 80, load balancer, type load balancer. Let's try host port. See what this does. Did not work. Let's actually do this. Let's not save it. Let's delete service. What was it? TGIK Nginx service. And let's do this again. But instead of type equal to load balancer, let's do type equal to host port and see what happens here. Then we can try cluster IP as well. Yeah, Duffy, that's all we're looking for. Cluster IP external name, node port. Why did I say host port? I feel like I always do that. Thank you, Tom. Yeah. Well, these names are interesting because they make sense to the implementation, but it's kind of hard and confusing for users upstream. So again, like Kubernetes is doing this delicate dance of trying to get the abstractions and the names right, and we get it right sometimes, and other times it can be confusing. But in this case, node port is the string we were looking for. And Duffy says because it doesn't need to, right? This whole network is the rule that exists. That's what I'm thinking, Duffy, but again, we can poke at this on a later episode as well when I have some more time to prepare a better network address translation example. I'm kind of like just trying this here at the end because we had a little bit of extra time. And it looks like Tom agrees with Duffy. Still nothing here. I'm going to say that's good. Let's, maybe Duffy, you can work with me and we can get an example of using IP tables to do some natting, either with Flannel or maybe even Canal or a different CNI provider. I think this is good for today. Flannel is a pretty bare bones implementation, and we were able to kind of glue everything together and learn about how Flannel works and learn about VXLAN behind the scenes and how it doesn't use multicast. So, being that we're an hour and 30 minutes into the episode already, I'm going to do the thing where I go back to my face and I say, thank you everyone for joining. We'll give folks a few minutes to say goodbyes or ask any questions or I ask about upcoming episodes or give shout outs or anything at all. These last few minutes are kind of like the fun time where we get to say goodbye to everyone and thank everyone for joining. And so one of the things that I always do at the end of an episode is I always have this filler moment like right now where I'm talking and folks say goodbye and ask questions and you need like a minute or two to kind of fill it with some information. So in this case, I thought what better than to look at pictures of my vacation while we have these last extra minute or two of stuff to talk about. So in this case, I have pulled up some pictures from my Instagram. I picked this one in particular because I am wearing flannel. Let me go back to my screen here. And we're talking about flannel today, but this is me ice climbing in a flannel dress because that's what I do on my vacation. We also have me and my partner and two of my friends on the Emmons Glacier. And this is us near the summit of Mount Rainier, near the Bergschrund, which is the largest crack at the top of a glacier. It's a German word. And if you can't really tell here, but this whole crack on the upper right side is about the size of a cruise ship. Several hundred feet of solid ice, and you can see it from Seattle, and it looks like a little teeny tiny line near Seattle. But you get up next to it, and it's actually this monolithic crack that we had to walk along where the ice had broken. So anyway, these are pictures from my vacation. I had a great vacation. I'm excited to be back to work. I feel really good. I've gotten a lot done already this week, and we're going to have a lot of fun in the upcoming TGIK episodes. So let us know if you have any ideas for other CNI implementations you looked at, if there's something we missed along the way that you would like to see. Big shout out to Tom. Thanks to everybody for joining. It's been a wonderful episode on Flannel and CNI, and hopefully we got to learn a little bit about the Kubernetes release process and how all of this CNI stuff kind of fits together. So let's see what we have going on in chat. Tom says, great explanation of Flannel and Canal. Tom says, thanks. Thanks, Chris. It was very interesting. Vikram says, thanks. Michael, I guess, is going back to AWS Cloud Provider Hell. See you later, Michael. And thanks, Tom, for the awesome work. And Vikram says, AWS VPC CNI. Yeah, that's one of the ones that we've been working on in City AWS, or actually I shouldn't say we've been working on, but the folks at Amazon have been working on. That would make a good one as well, and we can learn how the cloud provider-specific implementation bits are relevant to the networking in Kubernetes. That might be a good lesson to learn. Looks like Duffy also agrees. Yeah, it would be a good one. So maybe we can tee that one up. I know we wanted to do Weave, which I think I might do that next. We had some folks ask about Multis, and then we discovered that whole list of third-party plugins in the open container networking, just container networking GitHub organization. So lots of CNI to come, and one of the things I've been thinking about is after we get done on CNI, we'll do a short write-up and do a side-by-side about what we learned, and maybe we can look at CSI next and learn about storage in Kubernetes for other TGIKs moving forward. So again, happy Friday, everyone. It's been a wonderful episode. I've been in here ranting for an hour and a half, so I'm going to go get some fresh air and enjoy our long weekend. I hope you all do the same, and have a great rest of your Friday, everybody.